Hello everyone, let's see this problem Weird Palindrome Making from November Challenge 2021. In this problem, the statement says that there is a weird language and there are n distinct characters in that language. Now we are given an array A which consists the counts of each character that we have to use in making a palindrome. To make a palindrome, we can make an operation such that we can select a character and replace all the occurrences of that character with some other character. Now let's understand the question with the help of an example. Let's take this example. These are the alphabets and these are the frequencies that are given. To make a palindrome, first of all, let's make a line which represents the left part and the right part of our palindrome string. So in this example, we are given that B has 2 count. So what we can do is we can place B on the left side and the right side of our mirror. Now D has a count of 4. It should be also placed evenly. So we place 2 Ds over here and 2 Ds over here. Doesn't matter how we place D, it can be placed before or after B. And the only letter that remains now is E. So we can actually replace this mirror with an alphabet that is E. So this makes our palindrome. And how many operations did we make in this example? Answer is 0, because we can actually make a palindrome without making any changes to the alphabets that are given. Now let's take another example. Let's draw the mirror. A is equal to 5. Now we cannot actually place it evenly on both sides of the mirror. B is also 3, that is odd. We cannot place it evenly. C is 6, we can place it evenly, so let's do that. Now D is 1, odd again. E is 3, odd again. So now let's start with A. Let's replace all the A's with B's, let's say. So the count that A now gets is 0 and B gets 3 plus 5, that is 8. Now 8 can be placed evenly. So we place 4 B's over here, 4 B's over here. Now the remaining part is D and E. We make D 0 and 3 plus 1, E is made 4. 4 can be placed evenly. So 2 E's over here and 2 E's over here. Now how many operations did we make in this example? The answer is 2, because we changed the alphabets A to B in one operation and D to E in another operation. So the observations that we can make from these two examples is that even numbers do not matter. All we need to take care of is the odd numbers. And one odd number, if present, can be handled easily because we can actually replace the mirror with that odd number. Now to make things more clear, let's take another alphabet in our second example and make the count to be odd. Now to make a palindrome in this example, we can actually replace the mirror and place 5 F's. Now the middle F acts as the mirror. So we can clearly see that the answer, that is the number of operations that we get in our solution, is actually equal to half the number of odd numbers that are given in our array. So in this example, previously there were 4 odd numbers, A, B, D and E. So the answer we got was 2. And in the next part, when we added 5, there were 5 odd numbers and the answer was still 2. So it was the greatest integer of the number of odd numbers present in our array. Now let's take a look at the code. We include the IOStream library, the standard namespace, our main function, then we take t to be the number of the test cases, we input t, we run a loop for each test case, then we take an integer n, n is the size of array or number of alphabets in weird language. Okay, now we input n, we run a loop for the array, now inside each iteration we take another variable d, d is the count of ith alphabet in weird language. We input d, another thing that we need to take care is we have to take a count of odd numbers, so we initialize odd to be 0, number of odd frequencies in our array. Now if d is odd, we increment odd, and the answer should be odd upon 2, simply because if odd is odd, then odd upon 2 will actually give us the greatest integer only. So let's try to submit this code. And the solution got accepted. Thanks for watching.